Eclipses of the moon take place 2 weeks before or after solar eclipses. After eclipsing the sun, the moon circles the Earth. 2 weeks later, it approaches the shadow of the Earth and passes through it. The shadow of the Earth is projected onto the full moon and turns it into a crescent. In ancient Greece, during an eclipse, Aristotle noticed the curve of the shadow on the moon. It was the proof he was looking for. Only an enormous round object could throw a round shadow on the moon. The Earth was round. During an eclipse, the shadow of the Earth advances and the moon darkens. But at the same time, it takes on strange colors. This is because of the sun's rays passing through the Earth's atmosphere like a sunset. Astronauts on the moon during an eclipse would see this sunset followed shortly afterwards by a sunrise. The next full moon won't pass through the Earth's shadow. It will go by slightly above it. There are only 2 lunar eclipses a year, and the next one is in 6 months. On the 20th of March, it was the beginning of spring. Sometimes spring begins on the 21st of March, and not the 20th. Why the delay? On the 20th of March at noon, the Earth reached its spring point. But as its daily rotation isn't synchronized with its long yearly voyage, this is what happens a year later. On the 20th of March at noon, the Earth hasn't yet reached its spring point. It's 6 hours away. The Earth will reach its spring point at 6 p.m. Spring will only officially begin the evening at 6. The year after, spring will again start 6 hours later. That will be at midnight between the 20th and the 21st of March. And in the 3rd year, spring will again begin 6 hours later. So there we are. This time we've reached the morning of the 21st of March. If we continued this way, the start of spring would shift farther and farther back. We're saved by the leap year when we add the 29th of February. By adding a day to the winter, we stop the Earth trespassing 1 day into spring. Every 4 years, in the year before the leap year, spring begins on the 21st of March. In other years, it's the 20th of March. Spring is beginning. Soon it will be Easter. But each year, the date of Easter changes. Christian tradition sets 3 conditions. Easter is celebrated after the spring equinox, after the first full moon of spring, and always on Sunday. The whims of the Earth-Moon pairing set the date for Easter. Here they are, approaching the spring equinox. The Earth passes the line, first condition met. But the moon isn't yet completely full. Four days later comes the full moon, second condition met. But it's Monday, and for Easter, we need a Sunday. So Easter will be next Sunday. Another year. When the Earth and Moon pass the equinox point, the Moon is only a half moon. This position makes Easter quite late. The Moon has to make almost a complete orbit before it's full, which takes 3 weeks. Ah, that's a Saturday, so we won't have to wait long. The next day's Sunday. It's Easter. Always on the Sunday after the first full moon of spring. When our watches show the time, they give us the position of the Earth in relation to the Sun. Normally, when the Sun passes the meridian of your town, it's noon. The Earth makes a complete turn in 24 hours. Every hour, a different slice faces the Sun, so the Earth is divided into 24 time zones. It's noon in Prague. The Sun is over Prague. 1 hour later, it will be noon in Paris. 1 hour after that, it will be noon in Lisbon, Portugal. 2 hours later, it will be noon in Brazil and Greenland too. Another 2 hours, and it will be noon in New York. To simplify communications between neighboring countries, natural time zones have been broadened into artificial time zones. Madrid and Prague find themselves in the same time zone, although they're 2,000 kilometers apart. At noon, the sun passes the Prague meridian where the clocks show 12. Everything's normal. But the sun takes nearly an hour to reach the Paris meridian. And here, the watches of the Parisians don't show midday, but almost 1 o'clock, Prague time. So the French keep Prague time. Each year we'll be changing to daylight saving time. We'll put our watches forward 1 hour. The sun will rise 1 hour later. The Earth is divided into 24 time zones. As we switch to summertime, we slip into our neighbor's time zone. In a large part of Europe, we're already an hour out, even before we switch to summertime. To simplify communications, we've replaced the real local time, which corresponds to the position of the sun, with a legal time zone, which matches Prague local time. In Madrid, Paris, and Warsaw, watches show the same time, although these 3 cities are in 3 different time zones. When we change our watches to summertime, we'll move our timetable 1 hour more to the east. The English will keep Prague time. The French, Istanbul time. The sun will pass the Istanbul meridian at noon exactly, and when the sun arrives over Paris, it will be 2 p.m. Istanbul time. The Earth's rotation won't have changed at all. The only thing that changes is the way we manage time.